All right, welcome back. So we're going to look at the next part of 7.1, which gets into the types of equations based on their solution set. So there's three types that we're going to be looking at, and one of them we've already tackled. So the first one says if an equation has a finite number of solutions, so a specific number essentially, then the equation is a conditional equation. So everything we've seen so far have all been conditional. So if r is equal to 0, this one's true. K is equal to 100, then this one's true. So there's a specific number of solutions. So that's one case, and it is conditional. The next one says if an equation has an infinite number of solutions, then the equation is an identity. Now we haven't seen that yet, but basically any number will work. Any number we plug in will make the equation true, which seems a little weird, but we're going to see how that can happen. And then the third case is if an equation has no solutions, then it is a contradiction. So no matter what number you try, it's never going to get it to work out right. So we're going to see what that kind of equation will look like in just a second. So let's take a look. So decide whether each equation is a conditional, an identity, or a contradiction. Give the solution set. All right, so it looks like a normal equation. So what are we going to do? Well, we're going to try to solve it. That's all you can do is try to solve it and see what happens. When you try to solve it, you're going to see something fishy going on when it's one of those other two cases. So we got some stuff on the left, we got some stuff on the right, we got some parentheses. So we want to get rid of the parentheses. Let's do that first. Now we can do some combining on the left-hand side, but we'll do that in a minute. So let's distribute that 2 into the parentheses. So we should get a 6k plus 8 minus 4. All right, so far so good. Let's simplify down and see what we get. So 9k and the 3k minus 3k, we can combine those together. So that's going to give us 6k. And we still got the plus 4. 6k is going to come down on the right side. And then plus 8 and a minus 4 is another plus 4. So we got 6k plus 4 and 6k plus 4. So some bells and whistles should be going off at this point because you got exactly the same thing on both sides. When you have exactly the same thing on both sides, that means it's an identity. So no matter what number we plug in for k here, we're plugging in the same number for k here, so those two sides will be equal no matter what. So this is an identity. So, okay, let's take a look at the next one. Very similar, let's do the distribution first. Negative 2p plus 5p minus 9, 3p minus 12 minus 5. Okay, not anything too drastic yet. Let's combine our p's. Minus 2 and a positive 5 should give you a positive 3p. We got our 3p minus 12 and minus 5 is a minus 17. Well, it's not the same on both sides. So it's not an identity. Okay, so what do we do now? Well, normally we work with the variables, right? We try to get them all on the same side. So let's try that. If we wanted to subtract 3p from both sides, though, you can see that the p's cancel out on both sides. So all you're left with is this weird statement that negative 9 equals negative 17, which we know is, that's not true whatsoever. So this one is going to be a contradiction. So when you get a weird statement that just doesn't make sense at the end, it's a contradiction. But the big thing is that the variables cancel out completely. Because you had the same thing on both sides, it's just the number parts don't match up. So in this case, we could have subtracted 6k from both sides and we would have got 4 equals 4. So that's always going to be true no matter what. So that's another way you can show it's an identity. So the variables do cancel out here, but they also cancel out in a contradiction. So just be careful. That's the only difference between those two. So what about this one? Well, let's see what happens. We had some parentheses. So we got negative 11m plus 4m minus 12 plus 6m equals 4m minus 12. All right, so nothing drastic yet. We got some m's to combine. There's 3 of them. So we got a minus 11 plus 4 plus 6. So what's that going to boil down to? Well, hopefully that's a negative 1m. And I already made a mistake. It's not plus 12 over here, it's minus 12, right? So be careful. It's easy to make little mistakes like that. The big thing is the follow through. As much as it's easy to make those mistakes, if you're showing your work along the way, I can give partial credit for that. It's when you don't show any work that kind of ties my hands. So definitely show your steps. All right, so now at this point, let's work with our m's. They're not the same. The numbers look, well, they are the same, but we got to combine our letters though. So minus 1 is smaller than positive 4, so let's add 1m to both sides. So we got negative 12 equals 5m minus 12. And now we got to get rid of all this stuff attached. So let's add 12. So the 12s cancel. They cancel there too, but if there's nothing left, what did we say? You got to leave something behind. So in this case, we'll leave the 0. And so now let's get rid of the 5 by dividing it. So m is going to be equal to 0. So which one of the 3 is that? You got it. Remember, when there's a solution, if there's just one of them, it's conditional. So there's your 3 types. All right, so let's cut this one short, and then the last part of this is going to be getting into solving formulas. So formulas are a little bit messier because they got even more variables, but it follows the same rules as what we've been doing. So we'll see it in a second.